our response, it's not going to be like this anymore, right? It gets scaled by this value, right? It also has another component to it, right? So let's analyze this. I'm just going to write this somewhere else. So we saw that if we have C of S plus alpha, our time domain response, it's going to be dC of dt plus alpha times C of t, right? Let's assume that alpha is a positive number. If alpha is positive, it means that we're gonna scale this, like this gets multiplied by alpha, okay? And also you add this this term to it. So like the derivative of this one, this is alpha times ct. Derivative of this one, it's gonna be something like this. So eventually becomes 0. So it's gonna be something like this. This is dc dt. Okay. So this is not very accurate, but I'm just like showing you using an example how things are gonna look like. So we have to add these two together. So our response, let's assume that alpha is very small. If alpha is very small, our waveform, it's gonna look something like this. Something like that. It's just not gonna be exactly the same. If I wanna add these two, it's gonna be something like this. It's not accurate, but let's just like, if alpha is bigger than 0 and it's a small, maybe something like that. So it's gonna look more or less similar to what we had before. It's a scaled, but its shape, it's similar to what we had before with some variation here because of this term, because of the derivative term. But if alpha is very big, then it means that the alpha ct, it's going to be very huge. So we might have something like this. Okay, so if alpha is small, if alpha is big. Okay. Actually the other way around, sorry, the other way around. So but more or less what I wanted to mention, that if alpha is bigger than 0, like our response is very similar. We might have some overshoot, we have some like small variations here, but it doesn't affect the stability of the system. It doesn't do anything about the stability. What if alpha is negative? If alpha is negative, now these two get subtracted from each other. So you might end up with something like this if alpha is negative. So it means that if you have a 0 on the right side, because if alpha is negative, it means that you have a 0 on the right side, right hand plane, right? Then because this term, it's going to get subtracted from this term, so you might end up with you definitely end up with a dip here, like it's just like an undershoot here before you start moving towards your final value. So this is like some of the impacts of having zeros, right? So it affects your settling time, rise time, overshoot, but it doesn't affect the stability, right? So we mentioned that we want to study both stability and performance characteristics, time domain performance characteristics. So having zeros can have some impact on settling time, rise time, overshoot, but doesn't impact the excuse me, doesn't impact the stability. Many times also this is not desired. We don't want to have this undershoot. So sometimes you can just cancel 1 0 using a controller. So let's say like, okay, I have right hand side 0. Let's say like what happens if I have a controller and I put it before here. So like instead of like you directly going to the transfer function, let's go to the controller and then goes to the plant, right? And in this transfer function, we try to cancel this one. So like we would have a term like this, that these two would cancel out each other. So we don't have the impact of that right-hand side plane 0. Okay, so that's the impact of a 0 that can have some impact and can basically change the performance of the time domain performance of our system. Okay, I'm just gonna leave this on. Okay, so again, like, so if our 0 is on the left hand side, we don't have any undershoot, but the waveform can change. We might have some overshoot. We might have some like some small variation here in the beginning because of this term. But if our 0 is on the right hand side, like we might have some undesirable undershoot that you can cancel it out using a controller. Okay, so that's the impact of having zeros in our transfer function. Now, so previously I mentioned one definition of stability based on like how the signal, what signals moves towards to as t goes to infinity. We had like asymptotically stable, unstable, or marginally stable. We have another definition for stability, which is called BIBO or BIBO stability. So we call a system stable if for any bounded input we would have a bounded output. Okay, so if we have a system that we provide a bounded input means that like it has like finite maximum and minimum, right? It would give us another bounded output, another bounded signal, which has like a finite maximum, finite minimum, right? So if for